Welcome to Academic Math. In this video, I will solve the last 3 questions of question number 2 of exercise 2 of the book Higher Algebra by SK Mapa. And in this question, a set S is given by Z by Z. That is, S is a set of ordered pairs of integers, and a relation rho on S is defined by an ordered pair AB is related to an ordered pair CD. An ordered pair AB is related to an ordered pair CD if and only if A plus D equals B plus C. Then we have to check that rho is reflexive, symmetric, and transitive. Reflexive, symmetric, and transitive. Since in Z we know that, as we know that AB will be related to AB if and only if A plus B equals B plus A. Since in Z for all AB belongs to Z, A plus B equals B plus A, therefore we can say that the ordered pair AB is always related to the ordered pair AB for all individual ordered pair AB in S, which implies that rho is reflexive. Here we can see that by the definition of rho, the addition of these two terms, that is A and B, the first element of the first ordered pair and the last element of the last ordered pair, is equal to the addition of the second element to the first ordered pair and first element to the second ordered pair is equal. That is, the addition of A and B is equals the addition of B and A, as it is happened in Z. Therefore we can conclude that rho is reflexive on S. Now to check the next, that is rho symmetric or not, let two ordered pair AB and CD belongs to S such that AB is related to CD. So we have to check that. Our question is that, is CD related to AB? This is our claim, that CD is related to AB. This is our claim, is that CD is related to AB. Now I will show that why this is true, because now we are checking that is CD related to AB or not. Now it is, we have already assumed that AB is related to the ordered pair AB is related to the ordered pair CD, and by the definition of relation rho we have A plus D equals B plus C, which implies that B plus C equals A plus D, and which implies that so if we check that CD is related to AB, then we have to show that the addition of C plus B is equal to the addition of D plus A. To show that, we will write this as this equation as C plus B equals D plus A, as addition is commutative in Z. And which implies that CD is related to the ordered pair AB, and therefore AB related to CD implies that CD implies that CD is related to the ordered pair AB for all arbitrary ordered pair AB CD belongs to S, which implies that rho is symmetric. So first we have already get that rho is reflexive, and in the next page we have seen that rho is symmetric also. Now our view is to check out that rho is transitive or not. To check the transitivity, let three element in S, that is three ordered pair, suppose AB, BC and ABCD. Sorry, this will not be, this will be CD, distinct ordered pair. AB, CD and EF belongs to S such that the ordered pair AB is related to the ordered pair CD, and the ordered pair CD is related to the ordered pair EF. Okay, we will check that AB is AB. Our target is that is AB related to EF or not. Since this is common here, the ordered pair CD is common here, we have assumed that AB is related to the ordered pair CD and CD is related to the ordered pair EF. This common ordered pair we have to eliminate, that is we have to check that the first ordered pair AB is related to the last ordered pair, that is EF, or not, is related or not. In the next page, by the definition of rho, we can conclude that A plus D equals B plus C, and here it is given that CD is related to EF, and therefore C plus F will be equal to D plus E. C plus F will be equal to D plus E. Adding 1 and 2, we have 1 and 2, we have A plus D plus C plus F will be equals B plus C plus D plus E, and now we can cancel out D from the both side and C from the both side, and therefore we can say that A plus F will be equals to B plus E, and which implies that AB is related to EF. AB is related to EF, and therefore AB is related to CD, and CD is related to EF, implies that AB is related to EF, and therefore rho is transitive. Hence we have finally get that rho is transitive, rho is symmetric, and rho is reflexive also. That is, rho is reflexive, symmetric, and transitive. Now I will solve the next question in the next page. That is question number D of question 2. That is question number 2D. In this question, a set S is given by Z by Z, and a relation rho is defined on S by AB is related to CD if and only if AD equals BC, and we have to check that rho is RST, that is reflexive, symmetric, and transitive. As AB equals BA in Z, that is AB equals BA for all AB belongs to Z, and which implies that the ordered pair AB is related to the ordered pair AB, which implies that rho is reflexive. This will happen for all the ordered pair AB in S. So we have rho is reflexive. This is the first observation. Now we will check rho is symmetric or not. Let the ordered pair AB and related to the ordered pair CD, where the ordered pair AB belongs to S. By the definition of relation rho, we have AD equals BC. We have to check that is CD. Our question is that is the ordered pair CD related to AB or not. So to relate to AB to CD will be related to AB if and only if the product of CB is equal to the product of DA. CB will is equal to DA, and which implies that BC equals AD, and as the multiplication is commutative in Z, therefore CB equals DA, as multiplication is commutative in Z, and which implies that the ordered pair CD is related to the ordered pair AB here, and therefore rho is symmetric. Now our target is rho transitive or not. I will try to show is rho is transitive or not. I try to check that rho is transitive or not. Let the ordered pair AB, CD and EF belongs to S such that AB is related to the ordered pair CD and the ordered pair CD is related to the ordered pair EF. Then we will check that is AB related to EF or not. If they are related, then we can say that rho is transitive. Now by the definition of rho, so we will check that is rho transitive or not, and by the definition of rho we have assumed that these two, and by the definition of rho we can write it as AD equals BC, this is number 1, and CF equals DE, this is number 2, and multiplying the left hand and right hand side of both the equation 1 and 2, we have ADCF equals BCDE. Now which implies that AFDC equals BEDC, but which does not implies that AF equals BE, that is we can't cancel out DE due to the possibility that D or DC, we can't cancel out DC due to we can't take the possibility of non-zero, that is if either D or C is 0, then we can't cancel out DC from the both side. So this will not imply that AF equal to BE. If that is it is given that DC is not non-zero, then we can cancel out. Since it is not given that DC is non-zero, since it is not given that DC is non-zero, so there is a possibility of becoming DC is 0, that is if D equals 0, either D equals 0 or if either D equals 0 or C equals 0, then we can't cancel out DC, and in that case this will not happen, and which implies that A B does not related to E F, and therefore rho is not transitive. So we have finally checked that the relation rho is reflexive. The relation rho is reflexive here, and symmetric here, and transitive here, not transitive here. Therefore, reflexive, symmetric, and transitive. This is reflexive, symmetric, but not transitive. Okay. Now, in this video, I will solve the last question, that is question number E of question 2. That is, question 2E is given by a set S equals n by n. Now, a relation rho is defined on S by AB is related to CD if and only if and only if AD equals, if and only if AD equals BC. That is the same definition that we have already previously done. Here the domain set, that is the set, it was Z, and but here in this question it is a set of natural number, that is 0 does not belongs to that natural number, and that's why it will be transitive. That is reflexive, it will be reflexive as well as symmetric and as well as transitive as the previous one. So in this question we have to check that rho is RST or not. That is, in this question we have seen that as AB equals BA for all AB belongs to Z, so which implies that the ordered pair AB is related to the ordered pair AB itself for all AB belongs to S, for all AB belongs to S, and which implies that rho is reflexive. Rho is reflexive. Now we will check rho is symmetric or not. Let two ordered pair AB and CD belongs to S. Two ordered pair AB and CD belongs to S, such that the ordered pair AB is related to the ordered pair CD, and which implies that AD equals BC, and which implies that BC equals AD, which implies that CB equals DA, CB equals DA, as Z is commutative with respect to the multiplication, and which implies that the ordered pair CD is related to the ordered pair AB. Okay, therefore, and which implies that rho is symmetric. Rho is symmetric. Now we will check the transitivity. Let AB, CD and EF belongs to S, such that the ordered pair AB is related to the ordered pair CD, and the ordered pair CD is related to the ordered pair EF, and which implies that AD equals BC by 1, and by the definition of the relation, and CF equals DE. Multiplying the left hand sides of both the equations and right hand side simultaneously, we have from 1 and 2 we have 1 and 2, we have AD CF equals BC DE, which implies that AF DC equals DE DC, since Z is commutative under multiplication, and which implies that we can cancel out DC from here, because which implies that AF equals BE, as it is known that DC is not equal to 0, since the set is, since DC are belongs to DC, all are belongs to the set of natural numbers, which implies that rho is transitive. Rho is transitive. Hence, rho is reflexive here, rho is symmetric here. We have already seen that rho is symmetric here, and rho is transitive here also. That is, rho is reflexive as well as symmetric as well as transitive. That is, rho is here an equivalence relation. Thank you. In the next video I will solve the next following questions.